Hello viewers, in today's class we are going to discuss yet another important problem from inequalities, right? So in this class we'll solve or we'll prove this important inequality, that is e raised to x is greater than 1 over 1 plus x for all x greater than 0, right? So viewers, we have already discussed these kind of inequalities in our earlier videos, and we have already seen different methods how to prove these kind of inequalities, right? So in this class, we'll see how we can prove this inequality by making use of the concept of derivative, right? So viewers, the derivatives is an important tool in solving these type of problems, right? So to solve this or to prove this inequality, the first step is to frame a suitable function, right? So whenever we come across with these kind of inequalities, we should first frame a suitable function, right? So here let us frame a function, say f of x is equal to, here we have e raised to x, and if we take 1 over 1 plus x to the left hand side, we get minus 1 over 1 plus x, right? So with the help of the inequality itself, we can create our function, right? So here I will assume f of x is equal to e raised to x minus 1 over 1 plus x for here we have x greater than 0, right? So now let us find out the derivative of f of x, right? So f prime of x is given by the derivative of e raised to x minus 1 over 1 plus x, right? Now see, the derivative of e raised to x is simply e raised to x, and then we have the derivative of 1 over 1 plus x, which is 1 plus x raised to minus 1. So we have e raised to x, and here we have minus, and we have minus 1 over 1 plus x whole square, right? So now the derivative can be written as e raised to x plus 1 over 1 plus x whole square, right? So whenever we prove these kind of inequalities, we first frame a suitable function, and then we find out the derivative of that function, right? So now our next aim is to test this function f of x for increasing function or decreasing function, right? So in order to test a function for increasing function or the decreasing function, we take the derivative, right? So now see, here f prime of x is equal to e raised to x plus 1 over 1 plus x whole square, right? Now see this term, right? So e raised to x is the exponential function, and this function is always greater than 0 for all values of x greater belonging to the set of real numbers, right? So the exponential function is always positive for all x belonging to the set of real numbers, right? So here we have x greater than 0. So obviously x greater than 0 are considered in this set, that is x belonging to the set of real numbers, right? So now let us consider this term, right? So here we have 1 over 1 plus x whole square, right? Now see, here we have x greater than 0, right? So x greater than 0 implies that we have to consider the positive values of x, right? And here we have the square term. So obviously a 1 over 1 plus x whole square is greater than 0 for all x greater than 0, right? So now we see that our derivative, which comprises of these two terms, e raised to x and 1 over 1 plus x square, right? So f prime of x is always greater than 0 for all x greater than 0, right? Because e raised to x is positive and 1 over 1 plus x square is also positive for x greater than 0, right? So our derivative is greater than 0, or f prime of x is positive for all x greater than 0, right? So we have seen that the derivative is positive, right? And from application of derivatives, we know that whenever the derivative is positive or the slope is positive, right? Because the derivative shows the slope of the tangent, right? So when the slope is greater than 0, it implies that the given function f of x should be an increasing function, right? And whenever the derivative is negative or less than 0, it shows that the function is decreasing, right? So in this case, the function f of x is increasing function because the derivative is greater than 0 for all x greater than 0, right? So now here quickly revisit the graph of increasing function, right? Because here we have shown that fx is increasing function, right? So let us take the graph of increasing function like this. This is f of x, right? So now let us take 2 points here. This point is x1, and let us take this point as x2, right? So the definition of increasing function, it goes like this: when x1 is less than x2, right, or x2 is greater than x1, then f of x1 should also be less than f of x2, right? So here f of x is an increasing function. We have taken 2 points, x1 and x2, where x2 is greater than x1. So obviously, if the function is an increasing function, then this distance or the ordinate is f of x2, this ordinate is f of x1, so f of x2 should be greater than f of x1, right? So now let us come to our function f of x, right? So here if we take x1 is equal to 0 and x2 is equal to x, right? So for this function, we'll take the first point as 0 and x2 as x, right? So when x1 is here less than x2, it implies that x1 is 0 and x2 is x. That is, x is greater than 0. So from this definition, f of x1, so f of 0 must be less than f of x, right? So f of 0. So let us first find out f of 0 by taking x is equal to 0 in this function, right? So f of 0 is equal to e raised to 0 minus 1 over 1 plus 0. So e raised to 0 is 1, 1 over 1 is 1, so this is 0, right? So f of 0 is 0. So 0 is less than f of x, right? So we have arrived at the conclusion that f of x is greater than 0, right? And f of x is e raised to x minus 1 over 1 plus x. This is greater than 0. And if we take this term to the right hand side, we'll get e raised to x is greater than 1 over 1 plus x for all x greater than 0. And this is our required inequality, right? So this is how, by making use of the concept of derivative and increasing and decreasing functions, we can solve, or we can prove these kind of inequalities.